Assalamualaikum, this is Muhammad Ghous and this is the lecture 1 of my course on quantum relativity, and this is the first lecture called SQS, Superior Quantum System. So first of all, let's elaborate the term quantum system. So let's say we're talking about a hydrogen atom. Let's say if we are talking about its dynamics and how it works, or a system of hydrogen atom, this is called quantum system. But then, what is superior quantum system? A superior quantum system is a system of macro level beings, like a box on which we apply the laws of quantum systems, like its superpositional states and wave function, etc. So, what happens if we apply it on it? In our daily life, we experience that when we observe any object at a macro level. Let's say this is an observer A observing the box. Now, according to the superpositional principle, when an observer observes this box in different frames of reference, like here, after some time, this observer observes at this point, let's say, or a different observation after some time. According to the superpositional principle, the box will change its state due to its wave function. But as we experienced that it will not. Well, what's the reason behind it? According to the de Broglie hypothesis, the existence of a particle depends upon observation of conscious being. So it states two hypotheses. The first one is, so let's make an example of superior quantum system. This is a system and this is an object, some random macro level object, and a superior quantum system always consists of an observer within the system and an observer outside the system. Now this observer is called final frame, which is always outside the system observing both the observer A and the object. Now this observer is maybe higher dimensional or maybe within the dimension. As according to de Broglie hypothesis, our observations affect the states of object, which concludes that maybe the macro level beings are always observed or continuously observed by some frame of reference or by some observer. But in our daily life, we don't observe that observer, and the reason behind it is that it is a high dimensional observer. If we write it mathematically, if we write it mathematically, it will look like something like this. Let's say this is a wave function of some macro level being. We assume that it exists in superpositional states. We apply this operator. Now there are many operators like momentum operator or position operator, but we use this operator. Now this operator defines that when we apply this operator on a wave function, on a random wave function, it is describing that this wave function is basically collapsed to form an absolute wave function, which is continuously observed by some high dimensional being or some within that dimension being. Now, this C represents consciousness, which is stating that some conscious being is observing the wave function of that object. Now, if we are describing it high dimensionally, it will look like uh, now the observed operator have more components. Let's say we are talking about a vector. It will look like this. Like this object has x direction, y direction, and z direction, and also a time direction, but in the frame of reference which is observed, or in which frame of reference it is observed, it is high dimensional. Means this is representing a four-dimensional observation, which stating that it is observed by some higher dimensional being, and this is representing a vector, which clearly stating that there's some higher dimensional being observing the wave function of lower dimensional being, which is making it absolute. And that's why we don't feel in our daily life it other states. Now our next lesson is final frame. A final frame, as I've said, it is maybe in high dimension or maybe within that dimension observing the object. Now, according to this hypothesis, the final frame must be single, because what if the final frame is more than one? In case of a C observer, these both are final frame. Now, this observer is observing A, B, and also that object. Means now, including the A, this whole system is now becomes a superior quantum system, and now this is the final frame. Means if final frame becomes more than one, the previous or the thing, the previous final frame becomes a part of SQS, and the other observer which you have, the previous final frame becomes a part of SQS, and the new final frame which you have written, it becomes the real final frame, which is stating that the final frame it will always equals to one. It will never more than one. That is the big difference between frame of reference and final frame. It includes another topic called conservation of existence and non-existence. Now, according to this hypothesis, it states another conservation of existence and non-existence. Now, according to this principle or this hypothesis, it says that any object at macro level, like this object A, in some frame of reference, like a B frame of reference, it is an observer observing the box, and let's say this is an observer C in higher dimension. Now, according to this principle, the object's existence and non-existence is conserved, which is stating that it maybe exists in some frame of reference, means it is absolute, and it does not show its other states of wave function, but in higher dimension it will show its superposition state, which is stating that it is it shows a non-existence nature in the frame of reference of higher dimension, and in lower dimension it shows its existing states, which is absolute, which is stating that every object at macro level has a existence frame and a non-existence frame. Like this observation affects this object. Absolute state at lower dimension and non-existing or superpositional at higher dimension. So this is the end of our lecture. Now, in the lecture 2, I will discuss its relation with general relativity to explain it in more further detail and explain final frame in more detail. Thank you.